I look like a bean. Alright, continue on. Electrical installations are classified according to their temperature rating. Okay, so here's your three classifications: 60 degrees centigrade, 75, and 90. Okay, that equates to 140 degrees, 167, and 194 degrees. Okay, so when you're talking about running next to, a TCU unit that keeps that mold at 350 degrees or whatever, then you're going to have to really deal with these types of wires. Because if you go down it much lower, your ambient temperature is going to be too high with these conductors. So you kind of look through here. You can see all the different. You've got RHW, THHW, THW, THWN, XHHW, USE, UF, and so on, RHW. Okay, what does R stand for? Remember when I wrote it up earlier? What type of insulation am I talking about when I talk about R? What? Thermoset, right? And T is what? Thermoplastic. Very good. Two H's?
High heat.
High heat. One? Heat. Okay. W?
Wet.
N? UF? Underground feeder. Okay. That's for direct burial. Okay, I know you don't know that.
Does that mean you don't have to put it in any
You don't have to put it in conduit, you can just lay it straight in the ground. Okay? The dirt, the whatever, the moisture in the water and the dirt, it's not going to affect the insulation. Okay? That also is sunlight resistant. So if you want to look at ampacity, in the 2008 it would be table 310.16. In the 2011, they got rid of this table, made it 310.15. B2A, I believe, is the table identification for that. Insulation 310.13. Overcurrent. Okay, we need to understand the types of circuit conditions. Okay, you've got normal circuit condition where everything is operating as it should. You've got open circuit, which is, if your switch is off, then you have an open circuit. And then you've got short circuit and ground fault. Okay, and then last, overcurrent. Overcurrent is any current in excess for which the conductor or equipment is designed. What should be the weakest point in your circuit?
Overcurrent device.
Overcurrent protection device. Normally stated as OCPD. Overcurrent protection device. Okay, that should always be the weakest link in your circuit, so that if something were to go wrong, you all of a sudden are pulling more current than you had been before, that opens up before your conductors fail. Okay, so in our circuit here, we plug this. Well, here's an easy example. My air conditioner in my doghouse normally pulls around 14 amps. Right? And then we've got a light on that circuit and a couple little fans. Okay. This summer I didn't clean it out for a while. Clean out the filters. Okay, which starved that air conditioning unit for air. So it had to work harder to move the same amount of air and cool it down. So it started pulling more and more amps. So it started pulling 17 amps. All of a sudden it started tripping my breaker because I'm pulling overcurrents. Okay, I'm overloading the circuit. Okay, so I had to take it out, clean it out, put it back together, went back to pulling 14 amps. It ran fine until it became starved for air. Okay, so remember all of your loads. If you're talking about a motor, if this motor is pulling a conveyor and you overload that conveyor, you're going to cause that motor to work harder. Okay, you cause it to work harder, it's going to pull more amps until it trips out. Okay, so that's a bad deal. So it's not only just, how many amps is this motor going to be pulling, it's how many amps is this motor going to be pulling when I overload it. Okay, I could have planned in ahead and, built in a little bit of excess, into my circuit, but that would be kind of a bad idea because then I'd be hurting my motor. Okay, So it's not only just the motor, it's the motor and whatever it's pulling causes more current. OCPDs, which stands for what? Overcurrent protection device of 800 amps or less, which do not correspond to a standard size, I'll round it up. So let's say we go through here, and we're going to do some of these later, but we figure out that we need 75 amps. Right? Our wire can handle, we need 75 amps of protection. You're not going to round down, right? Our load comes up to 75 amps. That isn't an actual circuit breaker size, so we supply it with an 80 amp breaker. Okay, that's what that's saying. Anything 800 amps or below, if you do your calculations, you figure out, okay, this motor and this motor added together comes up to 75 amps, and you go to the next size bigger. Okay, so that's what that's saying. 800 amps or larger do not correspond to standard size or then rounded down. Okay, I doubt you guys will ever see anything over 800 amps. So I don't know. I mean, I know Camoplast has 1,000 amp main, but I don't see where you guys would be messing with that too much. So if you're going to mess with something that large, you need to be a well-trained electrician because you're dealing with a lot of power in a very high, a very explosive situation. If something were to go wrong, that'd be really, really, really bad. All grounded conductors are not always neutrals. Okay, you don't always have a neutral. Most systems, yes. Not all systems. What it's showing here. Here's your transformer. You have your three phases. You have three hot phases. You have 480 volts between each one. They are hot. Okay? You don't, when you're talking about like a three-phase system, you don't have a neutral when you're dealing with a three-phase system. Okay? You don't always have a neutral. Just remember that. A white wire is not always a neutral. 10-foot tap rule permits tap connectors to be supplied from a feeder without overcurrent protection at the point where they receive their supply power provided 5 conditions are met. So what they're talking about, 10-foot tap rule. So if I have a panel here, and I have a panel not more than 10 feet away, I don't need to go through this, then over. I can just come in, and right back out and over. That's a 10-foot tap. Okay? 25-foot tap rule permits tap connectors to be supplied from a feeder without overcurrent protection upon where they are supplied, provided 4 conditions are met. I'm not too worried about that. I'm not too worried about that, or that, or that. Alright. We get back to some of the rules from last chapter. How many feet apart horizontally should receptacles be?
12 feet.
12 feet. Okay? Means no spot on the wall should be more than 6 foot from a receptacle. This is talking about overcurrent devices. Your breaker panel, your fuse panel. Okay? Are not permitted in closed closets or bathrooms. Why not closed closets? Not always. Closets are kind of a special thing. They can either be calculated as inhabitable or not inhabitable when you're talking about lighting. Why else?
So not easily accessible.
Not easily accessible. That's very good. What else? What's in a closed closet? Closed. Closed burn. Burn equals bad. Okay. It's flammable. There's flammable components in, very close. So you don't have them in there, and then of course I would hope you would understand why you don't have them in bathrooms. So if you don't, then you probably need to.
So that's just strictly for a closet that you're gonna have clothes in. So
No.
for instance, if it's in my apartments and my panels in my utility closet.
A utility closet. What do you mean?
Like my air handling unit and my hot water heater are both right in there in the same closet along with my panel.
No.
It's not supposed to be like that.
It was just like that.
Is it readily accessible? If
Is
you
it?
had to, could you find it in the dark?
Well, I mean, you open the door and it's right there. There's nothing in the way of it. If you just open the door, it's right there on the opposing wall. And then the air handling unit's on one side, and the hot water heater is on the other side.
It has to be readily accessible. Meaning, behind doors, it's not readily accessible.
Well, I didn't put it in, so.
Right. No, there's, and when it was put in, it probably was up to code. You know, codes change. You know, it's just the way it is. You don't have to retrofit it unless you go in and do remodel work. Then you have to retrofit it. But if someone walked in, they don't have to make you change your